Okay guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 19 sa ating set theory. So this topic is all about divisibility. So definition, so focus lang tayo dito. So if A and B element is integers, we say that A divides B denoted by A and slash B, that symbol, if there is an element K element of Z such that B is equal to K. So again, ulitin ko lang in notation. A divides B, so meaning A divides B, if and only if, so pwede magkabaliktaran, B is equal to AK for some K element of integers. Okay, so yun ay ibig sabihin ng divides. So ideally, ano ibig sabihin nito? Ito yung baliktad na division. So kung alam mo yung 4 divided by 2, 2 divides 4. Okay, so ibig sabihin lang dito, we all know that 4 divided by 2. So in this case, this is if and only if dito, that 2 divides 4. Okay, yan yung ibig sabihin. Yan dito. Okay, so remark lang muna tayo konti. So remark number 1. Number 1 lang. So kung naalala ko, 1 divides A. So any number is divisible by A. Number 2. Number 2 A divides A. So divisible ka sa sarili mo. Tama yun. Number 3 na remark, that A divides 0. So for all A element of integers. So 0 is always divisible to any number. So tama yun. So parang sabi nga, 0 is also a multiple of any integer. Ano yung mga ibig sabihin yan? Okay, so let's have theorem. So ngayon magpuprove tayo ng mga theorem dito sa ating divisibility. Tapos mamaya magpuprove ako ng example in which baliktad yung scenario. Hindi na siya divisible. Kumbaga 3 does not divide something na ganito. Kasi puprove natin siya. Okay, so let's have theorem number 1. Sabi ng theorem number 1 that A, B, C, D, R, and S, okay, so sobrahan lang ako dyan, element ng integer such that D is not equal to 0. Okay, if D divides A and D divides B, then D divides RA plus SB. So yun nga yung gusto niya mangyari, no? If D divides A and D divides B, then RA plus SB, D divides RA plus SB. So paano ba i-prove? Yung ganito. So ito yung proof. Note na ito yung mga ano, no? Ito yung assume, ito yung premise, ito yung conclusion. So go natin mapunta sa premise. So yung premise natin o yung assume natin, D divides A. This implies, or this is if and only if A, tama? A is equal to D K for some K element of integers. Next, D divides B. This implies that B is equal to let's say B, no? So this is D K sub 1. So there exists K sub 1 element of integers. So K sub 1 yung ginamit ko para hindi redundant. So sa proving, para mas elegant din actually. So next is ang goal natin, dapat maging D divides RA plus SB. Okay, so note na ito yung equation 1, equation 2. I-multiply ko yung equation 1 by R, kasi RA yung kailangan. I-multiply ko yung equation 2 by S. So multiply R to, let's say, equation 1. So multiply R in equation 2, in equation 1, and multiply, so same, multiply S into. Okay, so ganun yung mangyari. So ano mangyari? Nung minultiply ko, siyempre pag minultiply ko dito, magiging RA. So we have RA is equal to RDK. Yung isa naman, we have SB is equal to SDK. Okay, note na kunin natin yung sum niya. Pag kinuha natin sum niya, this is RA plus SB is equal to RDK plus SDK. Okay, note na may common factor to. O DK sub 1, sorry. Okay, note may common factor to, which is D. So this is RA plus SB is equal to D multiplied by RK plus SK sub 1. So set lang natin na C, may C na pala, sorry. Sobrang kasi ako sa mga ginamit dito. So let's see, B equal sa RK plus SK sub 1. So we will have, ito na, so we will have RA plus SB is equal to DC. Okay, since by definition of divides, babaliktarin ko lang, since may nag-exist na C na element ng integers, so for some C element ng integers, this implies that D divides RA plus SB, and this is done. Okay, so ganun siya kasimple. Next, theorem number 2. Let A, B, C element ng integers such that A is not equal to 0 and B is not equal to 0. If A divides B and B divides C, then A divides C. So, ganun ulit. Premise, conclusion. So, our goal is to prove yun. So, this is the proof. So, unang assumption, A divides B, this implies, so A divides B, this implies B is equal to AK for some K element of integers. Next, B divides C, this implies C is equal to B K sub 1 for some K sub 1 element of integers. So as long as dinidefine, huwag nyo rin kalimutan yan. Okay, next is note that B is equal to AK. So consider natin to, no? So consider si C is equal to B K sub 1. Since B is equal to AK, pwede ko patan yung B doon. So this is C is equal to AK tapos K sub 1. So set natin na C is equal to A times K then K sub 1. Then set lang natin. So set M to be K and K sub 1. So we have, ito na, so C is equal to AM for some M element of integers. Then by definition of divides, A divides C. Okay, and that is done. So napaka-simple. Next, ito. So this is if and only if. So may case 1, case 2. So dapat ganun yung mababasa, no? So ito yung mga parang hypothesis. So ano ba pinagkaiba ng hypothesis kay assumption? So hypothesis parang siya yung mga, kumbaga, may mga true values na eh. Kung may mga true values ka na involved, then papatunayan mo yung proposition. So ito yung proposition, that is a biconditional proposition. So case 1, A divides B, it implies A sub AN divides BN. Then case 2, AN divides BN implies A divides B. Ayun yung mga dapat natin patunayan. So ayun, punta tayo dito. Yun, nakakapagod na rin. Kasi tayo dito. So again, yung mga hypothesis ha. So hypothesis. Ito yung proof. Note yung mga hypothesis natin. Note that A is not equal to 0 and K is not equal to 0. So I think magiging useful kasi yan eh. Yan. So case 1. For case 1, assume natin. So assume A divides B, show that AN divides BN. Okay, so I think iba to, no? I think N to. Kasi sige, wala naman tayo pakialam yan eh. Pakibago, I think N yan. Okay, so ito yung goal. So from assumption, A divides B. Since A divides B, by definition of divides, this is if and only if B is equal to A, K. Okay, so for some K element of integers. Okay, since n is not equal to 0, we can multiply n both sides. So, pwede kong gawin, mag-multiply ako dito ng b ng n, tapos raised akn. So, nag-multiply lang ako ng n both sides. Since n is not equal to 0. So, arrange ko lang konti ito. So, this is bn is equal to an times k. Then, this is for some k element of integers. So, by definition of divides, an divides bn. Okay, so that is case 1. Okay, so next is case 2. Case 2, assume an divides bn. Show that a divides b. So, I think mas mabilis to. Mas madali to. So, since an divides bn, this is if and only if, or implies. So, bn is equal to an k. Okay, then again, since n is not equal to 0, pwede natin i-divide both side by n yan. So, this is bn is equal to an k. So, ang gagawin natin is multiply lang natin sa 1 over n yung whole equation. Then, magiging dating niya, that is b is equal to ak. So, for some k element of integers pa rin. So, this is for some k sub 1, sub 1 element of integers. K sub 1. So, bakit naging k sub 1 ako tas k? Kasi nga, nasa isang proof. Pag ginamit ko yung k, parang redundant siya dito. Ganun yung ginagawa ko. So, by definition of divides, a divides b. So, in any case, this is done. Okay, so ganyan mag-prove dito sa ating divisibility sa number theory. Under the set theory pa rin syempre. Okay, so let's have example dito sa under sa divisibility. So, ang gagawin ko is hindi na yung normal na divisibility or divides. Gagawin ko is may contradiction sa loob. So, for example, yan tulad yan. If 3 does not divides x squared minus 1, then 3 divides x. So, meaning yan does not divide. So, hindi masasatisfy yung definition ng divides natin. Okay, so proceed tayo dito. So, paano ba natin ipoprove yung number 1? So, ito yung proof. So, by the way, naalala nyo, no? So, yung direct, paalala ko lang ulit. Yung direct is P implies Q. Yung indirect, ano ba yung indirect? Indirect is not Q implies not P. So, yung parang contrapositive niya. Okay, so aware kayo na true to. True yan. Okay, so magpo-prove ako by indirect proof using dito. So, proof by indirect. Proof by indirect. So, parang contrapositive. Kasi aware kayo no, na yung P implies Q is logically equivalent sa not Q implies not P. That is contrapositive. So, yung truth value na is 1. So, pwede natin gawin yun. So, proof by indirect proof, ano mangyayari? If nare-revise to, if 3 does not divide x, then 3 divides x squared minus 1. Yan dapat yung mangyayari. Okay, so punta tayo dyan. Suppose na tayo sa contrary na yan. Ito na mangyayari, no? So, 3 does not divides x. So, may dalawang bagay na mangyayari dyan. If 3 does not divide x, may two things. So, two things may happen. Okay, una, 3 does not divide x, or yung case 1, mali ako dyan, case 1, x divided by 3 with remainder 1. So, pansinin nyo mabuti. Kung yung x natin hindi divisible by 3, so, kunyari, divisible siya by 3. Pag divisible siya by 3, ang mangyayari, remainder 0. Tama. Ngayon, kung hindi ako divisible by 3, may dalawang klase mangyayari. It's either may remainder 1 ako, pangalawa, may remainder 2 ako. Ganun lang yung possible mangyari. So, mag-isip ka ng number na hindi divisible by 3. For example, 22. 22 divided by 3, so that is 7, remainder 1. Okay, next is 25. 25 divided by 3, so that is 8, remainder 1 pa rin. So, next is 26. 26 divided by 3, so that is 8, remainder 2. So, tatlo na yung case nangyari. Pag divisible, remainder 0. Pag hindi divisible, may remainder 1, may remainder 2. Pag sa divisible by 3. Okay, so case 2, x divided by 3 will leave a remainder 2. So, ayun ang dalawang possible na mangyari. So, we need to prove to na dalawa yan. So, ano mangyari? Una, case 1, ito ko nalagay. Sabayin ko kulay. Case 1. Case 1. 3 does not divide x. So, this implies, yung unang case natin, x divided by 3, remainder 1. So, ano mangyayari dyan? That is x is equal to 3k plus 1. So, for some k element of integers. So, ayun yung unang nangyari. If 3 does not divide x, yung unang nangyari, x divided by 3, remainder 1. So, that is x is equal to 3k plus 1. May remainder 1 tayo, kaya may plus 1 akong nilagay dyan. Ayun yung ibig sabihin yan. Okay, so, siyempre, ang set natin, dapat napakita natin na siya ay divisible by x squared minus 1. So, una, check natin sa x squared. Kasi ito yung papatunayan eh. Ito yung assumption una, dito tayo pupunta dapat dito. Okay, 3 divides x squared minus 1 dapat. Or somewhat dapat meron tayong contradiction na magawa. Okay, so proceed tayo ha. So, ang mangyari, consider natin si x squared. Okay, so si x squared ay equal sa 3k plus 1 raised sa 2. Tama? Kasi yung x eh. So, pag in-x squared ko siya, so pag na-raise ko to siya, i-raise ko lang to sa 2. So, this is equal to, this is 9k squared plus 6k plus 1. So, di ba x squared pa rin naman yan. Okay, ililipat ko yung 1 doon. So, this is x squared minus 1 is equal to, meron 9k ta 6k. Okay, so papactor out ko yung 3. So, meron matitirang 3k squared plus 2k. Okay, so iset lang natin. So, set natin na m is equal to 3k squared plus 2k. So, therefore, ano mangyayari dito? This is x squared minus 1 is equal to 3m. So, for some m element of integers. So, by definition of divides, 3 divides x squared minus 1. So, nakaisa na ako. Okay, next case 2. So, for case 2, – 3 does not divide x. This implies that x is equal to 3k plus 2. So, 3k sub 1. So, for some k sub 1 element ng integers. Okay, so ano mangyayari? Siyempre, ganun ulit. Same approach. I-x squared ko, or I think mas mabuti is kukunin ko yung, kunyari in square ko yan. Sobra, no? So, ang mangyayari is sobra pala siya. So, what if ang gawin ko is kunin natin yung x squared minus 1. So, check natin. Check natin yung x squared minus 1. Kung anong lalabas sa x squared minus 1. Check ko na lang din. Or start tayo sa x squared. So, x squared is equal to 3k sub 1 plus 2 raised sa 2. So, x squared is equal to 9k sub 1 squared plus 6k. Tama ba? That is 12k, sorry. That is 12k sub 1. 12k sub 1 plus 4. Okay, so ang gagawin ko, hihiwalay ko yung 1 dito. That's gagawin kong 3 plus 1. So, yung 4 gawin kong 3 plus 1 para yung 1 dadaling ko sa kabila dito. So, mangyayari, nagiging x squared to minus 1, which is equal sa 9k sub 1 squared plus 12k sub 1 plus 3. So again, nasan yung 1? Yung 4 naging 3 kasi yung 1 dinala ko dito. Okay, next. Note na pwede ko i-factor out yung 3 dyan. So obvious naman na yun. So this is x squared minus 1, which is equal sa 3 times 3k sub 1 squared plus 4k sub 1 plus 1. Okay, so set lang natin ulit. So set that kunyari p is equal to 3k sub 1 squared plus 4k sub 1 plus 1. So we have x squared minus 1 is equal to 3p. So for some p, element of integers. So by definition of divides, 3 divides x squared minus 1. Okay, so since the contrapositive is true in any case, therefore 3 divides x, and this is done. Okay, kasi nga tama yung contrapositive natin. Okay, so hoping na naintindihan mo yung case na ganito, yung does not divide. So hindi laging 1 and 2. Kunyari 5. Pag 5, 4 yung case. Bakit? Remainder 1, remainder 2, remainder 3, remainder 4. Ganun yung mangyayari. Okay, so tandaan yung mga ganyan. So kunyari 7, so may 6. 1, 2, 3, 4, 5, 6. May remainder 1, 2, 3, 4, 5, 6. Ganun yung mga possible na mangyari. Okay, so for number 2, show that 3 divides 2n squared plus 1 if and only if 3 does not divide 3n. So automatic, may dalawa tayo dapat i-show dito. Case 1, this is P, this is Q. Case 2, this is P, this is Q. So P implies Q, Q implies P. Parang ganun yung mangyayari. Okay, so for case 1, so here's the proof. Okay, so for case 1, so case 1, yung assume natin that 3 divides 2n squared plus 1. So goal or show, so ang show natin is 3 does not divide n. Okay, so paano natin atakihin to? So note that this P implies Q. So what if i-prove ko siya by RIP? So proof by RIP. So kung naalala nyo, no, ito ay naka-pattern na P implies Q. So by RIP, ang mangyayari, so by RIP, P implies not Q. Tapos maghahanap tayo dapat somewhere ng contradiction sa loob. So ang gagawin ko, marirevise ko yung show ko. So yung bagong show ni sir is 3 divides n. Kasi yun yung negation ng 3 does not divides n. So 3 does not divide n, negation is 3 divides n. Okay, so ito na yung goal natin. So somewhere dapat dyan makahanap tayo ng parang tawag dito, yung parang contradiction. So ano bang gagawin natin? So paano ba? Si 3 divides n, so assume ko yun, no? So kung si 3 divides n, therefore may mag-i-exist na k somewhere doon sa taas. Pero isipin ko 8. Okay, so I think mas mabuti dito ko siya ipakita. Diba ganito? Yung 3 divides 2n squared plus 1, para mapakita natin na 3 is divisible, 3 divides 2n squared plus 1, dapat makita tayo ng 2n squared plus 1. So somewhere that makita divisible yan by 3. Ganun mangyari. Ngayon, may ilalagay si sir dito. Aware tayo na 3 divides n yung show. So since 3 divides n, this implies that n is equal to 3k. So for some k, element of integers. Okay, so what if yan yung gamitin ko dito? Substitute ko. So check natin, since pinasok ko siya, so parang siya yung true sa loob, pinasok ko siya, kinuha ko lang muna siya. Okay, so mangyari, this is 2 times 3k squared plus 1, which is equal sa 2 times 9k squared plus 1, which is equal sa, lalabas ko yung 3, Okay, then may matitan 3 times 2, that is 6k squared plus 1. Kung napapansin mo, never ako makakapag-factor out ng 3 dyan. Okay, so pag ginamit ko yung value na 3 divides n, anong nangyari? N is equal to 3k. So pinabstitute ko dyan. So anong nangyari? Walang lumabas na 3. So this implies that 3 does not divide si 2n squared plus 1. So again ginamit ko yung show. So sa show kasi ito yung mga abangan ngayon. What if yung show ginamit ko sa assume? Nung ginamit ko siya sa assume, si assume kasi 3 divides 2n squared plus 1. Pero anong nangyari? Nung ginamit ko na yung show na makakukuha natin supposed to be, nung ginamit ko siya, 3 does not divide n. So meaning, ito yung P, ito yung not P. So meaning, ito yung contradiction. Okay, since nakakita na contradiction, so yun yung P and not P, therefore meron nag-exist na 0, therefore 3 does not divide n. Kasi nga, ganun nga, pag 3 divides n, hindi mangyayari to. Yung kabila, yung assume natin. Okay, so next is case 2. Paano yung case 2 natin yan? So, baliktad yung assume, no? So, assume that 3 does not divides n. Show that 3 divides 2n squared plus 1. Okay, so I think ito pwede na yung ginawa natin kanina. Na to, since 3 does not divides n, may dalawang case na mangyayari. Tama? Case 1, for case 1, so sub case 1, so sub case 1, okay, sub case 1, yung 3 does not divides n, this implies that n is equal to 3k, may nagamit na akong k kanina, so 3k sub 1 plus 1 for some k sub 1 element ng integers. Yan yung sub k sub 1. So, show natin sa show yan. So, consider natin si 2n squared. So, consider si 2n squared plus 1. So, this is equal sa, saan equal yan? That is equal sa 2 times 3k sub 1 plus 1 squared plus 1. Tama? Then, pag in-expand, this is equivalent sa 2 times 9k sub 1 squared plus 6k sub 1 plus 1 plus 1. Okay, then pag minultiply natin yung 2, so this is 18k sub 1 squared plus 12k sub 1 plus 2 plus 1, so this is plus 3. Okay, so may factor out ako na 3 dyan. So this is equal sa 3 times 6k sub 1 squared plus 12k sub 1, plus 4k sub 1 plus 1. Okay, so nangyari 2n squared plus 1 is equal dito. So set lang natin. So set m to be 6k sub 1 squared plus 4k sub 1 plus 1. So this is equal sa 2n squared plus 1 is equal sa 3m. So for some m element of integer. So by definition of divides, 3 divides 2n squared plus 1. Okay, so for case 2 or for sub case 2. So for sub case 2. So for sub case number 2, so 3 does not divide n. This implies that n is equal to 3k sub 2 plus 2 for some k sub 2 element of integers. Okay, so for formality talaga yung paglalet dyan. Okay, so next is, siyempre, consider ulit natin yun. So, yung ano natin, so 2n squared plus 1 is equal to 2 times 3k sub 2 plus 2 squared plus 1. So, pag in-expand, this is 2 times 9k sub 2 squared plus 12k sub 2 plus 4. Okay, then plus 1. Okay, so note na equivalent yan, that is 18. That's 18k sub 2 squared plus 24k sub 2 plus 8 plus 9. Okay, so pansin nyo, divisible by 3. So this is equal sa 3 times 6k sub 2 squared plus 8k sub 2 plus 3. So set lang natin ulit. So, set natin na si P naman to. So, set P to be 6k squared, k sub 2 squared plus 8k sub 2 plus 3. So, magiging revise. So, magiging mangyari, that is 2n squared plus 1 is equal to 3p. So, for some p, element of integers. So, pwede nang gamitin yung definition of divide. So, by definition of divides, 3 divides 2n squared plus 1. So, therefore, this is done. In any cases and subcases, this is done. So, ganun siya kahaba. So, hoping na naintindihan mo yung divisibility. So, magiging useful to lalo pag nag-abstract algebra ka, saka nag-number theory. So, that's all and thank you for watching.